Hey guys, welcome to Deep Dive Coding. Today we solve a LeetCode problem of the day. That is a hard problem and maximize the number of partitions after operation. So in this video I will explain how to approach this problem and how to apply the digit DP in such a problem. So it will basically a dynamic programming problem. So let's start the video. So the problem is basically says that we are given a string s and an integer k, and we have to perform at most one operations. We are allowed to perform at most one operations, and the operations is we can change any characters in s to other characters in lower case English letter. And after these things done, what we have to do, the maximum number of partitions we have to find the maximum number of partitions. The partitions is going such a way that we choose the longest prefix of s containing at most k distinct characters. So we start from the initial positions, and we are go until the unique distinct count of characters k. So when it is exceed the k, we just change the next, we go to the next partitions and we delete the prefix of it. So that's how it will going to be calculated, and we have to find the maximum number of resulting partitions. So now let's take an example of it. First example is a c c a and k equal to 2. So if you do not perform any operations, like if you do not change any characters of it, so it will uh, in the first operations, let's say we are taking longest prefix, so a c c c a, so it will take all the whole string as in one chunk because k equal to 2. So a and c both are the two unique characters over here. So in a first operation you can take a whole chunk of it. So this will give you the answer 1. So I will show you that. Okay, so first we are taking this example, similar example, and no change of it, no change the s equal to same, like we did not perform any operations of it. So one possible chunk is the whole string, and let's change the s of 1 equal to, that means this c, to any other characters rather than c. So let's say we are taking that character as b. So s modify will looks like this way, that a b c c a. So we have possible two chunks, one is a b and another one is c c a. So these two have the at most these two have the k unique characters, at most k unique characters, so distinct characters. And another thing is like, let's take a s equal to 2, s of 2 index, that will change to the b other than c. So this will be b, and s modify will looks like a c b and c a. So there are three possible chunks. First one is a c, this one, these two, then b c, and last one is a. So there is three possible chunks is possible. Another thing is like, let's try to index 3. So we change this c to the b. So there is also two possible chunks, one is acc and another one is ba. So our main task is to identify which string index change to which characters, like which index we have to change so that it will give you the maximum partitions. That will be our challenge. So to do that, we try to brute force all the possible character change. So if we change each characters to other characters like a to z, and we are calculating each iteration, we modify the string and calculate the how many partitions is possible and take the maximum. That will be the brute force approach. But if you think it closely, like there is so many overlapping cases. Let's say you string the same string as the first example, and you change s of 0 to z, like apart from a, you are changing this a first a to any other characters. Let's say it will be z. So first chunk is possible is zc, because this is converted to z. So zc is the first chunk. Okay, yeah, this will be, yes. So not this one, let's try to change let's try to change one as a z. So this character would be z. So you get az, and further we have to process the cca. Another one is, if you change this one, the one index, to y, then it will give you the ay and you have to further proceed CCA. So if you closely look into these things, like we change over here, like this one index C to Z and C to Y, and we have to process these characters, like this chunk like CCA again and again. So there are so many overlapping cases. So from here also we can get a hint of the dynamic programming. Apart from that, if you closely look into the constraint over here, so constant is okay. So s dot length can go up to 10 to the power 4 and k can go up to 26. So from these low constraint you also get the hint of the dynamic programming. So let's try to define the state of the dynamic programming. I will show you how to do these things. Like first of all we have to iterate over here, like iterate over the string. So we need the index, so index the current positions in the string. And another thing is can change, like we are allowed to change only once, at most once. So we are taking a boolean flag. If it is true, that means we can still change, otherwise it is false. Like once it is changed, we are passing the can change is false. Apart from that, we have to efficiently calculate the how many unique characters in the current partition. So to do that, we have 26 unique characters possible in the English lowercase. So and in the integer, like integer in any programming language can save in the 32 bits. So we can save that thing in only one integer only. We are taking a current set. This will a Bitmask representing the characters represent in the current partitions. Like current set is in int, so it will have the 32 bits, and English lowercase characters have 26 bits. So for each bits we are considering the whether it is occurred or not. Like similar, like for an example, s equal to abc, and if you look into this thing, like so the current set would be the 0, this one for a and this one for b and this one for c. So similar way we are checking the whether it is occurred in the bit or not. So to get the count of it, that how many unique characters, like number of unique characters occur, that will simply the number of set bits in current set integer. So now let's try to code. You will get the things eventually. So first of all we did not want to again and again copy the string s, so I will take as over here and int k. Okay, so we have to set over here also, like is this, we use the this arrow operator, so it will s and this k would be k. We are setting s and k. After these things done, we are defining the recursive function. So this will be recursive helper function. So we need to find, first of all I will show the recursion, then I will go to the memorizations part. So let's take a function name find max partitions. This will take let's take index. Another thing is we are ll means, that is we are define over here that ll is long, we are just using so that it will not overflow anyway. So this will be the current set as I discussed below. So another thing is boolean can change. No, so first of all we have to define the base case. So base case would be if the index value equal to s dot size, that means we are we already processed the last characters of string and we are go out of bound, so we have to return 0 because further after that partitions is not possible. Apart from that, we take the character index, current character index, that will be current character index, that will be s of index minus a, so that we get the current character index. So I mean to say that over here let get current character index, for example 0 for a and 1 for B, and so on up to Z. That will be the 25 for the Z. After we extract the current character index, we just update our current set. So current set updated, that will be the current set, or we push this thing and this will be the character index. Okay, so what is going over here, I will explain it. So the basically what we want to do, this will update the current updated set, like add this character to the current set for like current set. This will be the Bitmask representation. What it means that current set is the how many unique bits is already present. So we are, as we are considering these characters in the current partitions, so we mark this is true. At that we are setting that bits true because we are taking these characters over here. So now take the distinct count, distinct count equal to, there is a function which is in HTL of C++, that will be the built-in pop count. Built-in pop count, we are pass over here current set updated. These functions will simply return the number of set bits. So that will be the our distinct count. Distinct count represent the number of unique characters in current partition. After these things done, we are store the result that will have different cases, and let's consider the case 1, first case. So if adding this current character exceeds the allowed distinct limit k, then we have to start a new sequence. So that means start new partition from this character. So if distinct count is greater than k, that means we have to start a new sequence. So the result can be 1 plus, because current we are counting the current partition, that is for y 1, and again we are recursively call the next functions of it. So find max partitions of index plus 1, and we also have to set these things in the current character index. I will show you why I can do these things, and currency can change. That means why we are again setting this bit, because already we cannot pass this current set, because we are already changed the current. Current set is basically represent the current partitions set bits. So we are starting a new partitions. That's why we are taking these first character current characters in the new partitions. So we have to only change this character only, we do not needs to or with last partition. So that's why we are just taking this one left shift operator of character index. We are, and after these things done, another case is case 2. So continue with the current partition. That means it will go in the else case, and result will be find maximum partitions of index plus 1 and current set updated. That will go over here, because we are taking the current characters in our current partition, and can change go as it is, because we are not changing any characters over here. After these things done, we are going to the next case, that will be the case 3. Case 3 is simple. If we still have the option to change the character. What it means? That means the can change is still true. That means if can change is true, we have to change, like we can change each characters of it and see the answer, how it is going to affect our answer. Now try changing each character, changing the current character to any of 26 possible letters. So for to do that, let's int a new character index equal to 0 and new character index less than 26, because it start from 0, and new char index plus plus. Now add this hypothetical character to the current set. Why I say hypothetical? Because we did not change the current set right now. So it will be new set. Let's take a new set that will give you the current, extending the current set of it. So, or we have to visit this character. So new char index. After these things done, we have to again check the how many distinct characters already considered in the new set. So that will be new distinct count. That will again the built-in pop count, built-in pop count of new set. We are passing this thing. Like over here, we are changing the current character to this new character index character, and we have to visit that also. We have to mark that character also. We have to set that particular bits in the current set. So we are get the new set of it, like new current set, new state, that will be new set. And we have to, like, again we are counting the how many distinct characters is already visited. So we have to check again similar way, that if it is already exceed the k, then we have to start a new, otherwise we go with we can ignore it. So if the new character causes distinct count greater than k, so we have to start a new partition. So if new distinct count greater than k, so it will, let's start a new partitions. That will be result equal to maximum of result comma 1 plus find max partition index plus 1. Similar way, index plus 1, and we have to mark this character also, new character index. Another thing is false. Why it is false? Because we already changed it, so we did not change any further operations. And otherwise continue within the same partition. That will goes in the else condition. So result would be the maximum of result comma find max partition. That will be index plus 1, new set, because we are considering current characters. And also this will be the false. Why it is false? As I have discussed, because we changed these characters. So now it's fine. At last we have to return the result, and over here we have to call this function. So this function is find maximum partition. This will be return find max partitions. It will take the index, current set, and can change. So it will be 0 0 and true, and plus 1. Why it is plus 1? Because we are counting how many possible partitions, like how many uh, why we are doing these things, like how many possible split over here. So split plus 1 will be the number of partitions, that's why we are going to plus 1 over here. So now let's try to run this code so that able to find the whether it is compiled perfectly or not. I will update the memorizations. Yeah, it's compiled perfectly, and also passed for the sample test case. Now I have to memorize these things. So memorize these things, there is important concept lying over here. That means we can memorize like whole this index, current set, and can change. These are the state change, so we have to consider these states in our memorizations. So it can be done in a single value, that will be, let's say, define a key. We index 27. I will write and then I will explain it. So or current set, it will go left shift of 1 and can change. What we do over here, we are whatever index is, we are just left shift of 27. We are take the 27 last bit empty, and after that we are or with current set 1 bit empty, this 1 bit for the can change. So last bit from the right to left, last bit which represent the can change, next 26 bits represent the current set, and other bits are represent for the index value. So this can be the key, and we have to check that whether this key is present or not. So to do that, we take another thing, that will map, another map. This will be long and int. So you can say that this is a cache. So over here we just have to find whether it is already present or not, like if cache dot count key, if it is present then it will return true. Then we just you have to return the cache key, and at the last we have to update after process each after process this state, current state, we store the result in the result array, like result integer. So we have to update this thing in the cache also, so that we can, if this problem occurs again, then we have to just return from the cache only. So cache of key equal to res. Okay, I think it's done. Let's try to run this code. Yeah, it's run for the sample test case. So okay, so uh, okay, so I have to show you whether it is like going to occur again and again or some subset of problem. So if it is hit this thing like cache count is true, then it will execute these things print statement. Let's try to run this code. I will show you that how many execute is executing, so that you will able to understand whether it is actually be the sub problem of each, like we are calculating again and again same some subset of problem. So there are so many executing statement. So just remove these things and submit it. Okay, now let's try to submit the code. Yeah, it's accepted. Thank you guys, thank you for watching. Stay tuned for more videos.